Let's get started. I would like to introduce KYZEN's own Will Sweet.
Thank you, Sherry. And good morning, good evening, and good night, depending on where you are in the world. Thank you for joining for what will be a short talk on the ongoing struggle of corrosion on steel, which I'm sure anyone that has anything to do with manufacturing of steel parts or anything like that has ran into corrosion one time or another. On the agenda for tonight, we're going to start off with types of corrosion and the consequences that come with those types of corrosion. We're going to move on to different methods and ways to prevent corrosion. And finally, we'll end up at evaluating different corrosion protection methods. Starting with the types of corrosion and their consequences, what corrosion is, in a nutshell, essentially, is just a chemical or an electrochemical reaction between a material, in this case, we're talking about steel tonight, and its environment that results in the deterioration of the material and its properties. So what that means is that the steel or the material will be dissolving or eroding or gradually eating away at itself. A couple of different types of corrosion that you can run into are listed below. One of them, galvanic. That one is not as common when it comes to most steel producing manufacturing capabilities. But that's when two dissimilar metals are immersed in the same solution. It's a conductive solution. So electrically, they become connected. And we'll show an example of this later on in the presentation. What is more common in steel manufacturing applications is pitting. Pitting corrosion is, again, it's not uniform, so it's almost random. It's a localized form of corrosion, so it's very hard to predict where it's going to show up on the part, and it is exactly what it sounds like. So I mean, it's going to pit, and it can even pit all the way through and make holes in your parts. So yes, corrosion, this common enemy around the globe. A few of the leading causes for corrosion in general are humidity or moisture in the air, elevated temperatures. There can be catalysts involved as well, whether that's chlorides or sulfates. Time, it takes time for corrosion to appear, and the season. I live here in the Midwest, so I always like to mention season because corrosion is much more prevalent in the summer, and that's when humidity and elevated temperatures are much more prevalent, at least in this area of the world. And typically, kind of like I alluded to just now, it's going to take more than one of these leading causes together working in conjunction to create that corrosion on your steel parts. So here in the Midwest in the summer, you'll see those elevated temperatures, and you'll feel more humidity in the air. And those two together over time makes it much more corrosion much more prevalent in the manufacturing facilities. Here are a couple of examples of the types of corrosion that I mentioned earlier. On the left, that is pitting. And like I was talking about, it's more or less random. It's not uniform around the whole surface of the part. And you can see these pits, some of them are deeper than others. And the deepest ones, obviously, they make a hole. They cut a hole all the way through the part. On the right is an example of galvanic corrosion. And so there's a brass screw with a mild steel nut on that screw. And you can see that the mild steel is the one that I guess receives the brunt of the corrosion because they are connected through the conductivity of the solution. Moving on to ways to prevent corrosion. The first thing that you're going to want to do, and when you're trying to prepare a part to be corrosion protected, is you want to remove all of the soils from the part. And yes, that is definitely including the existing corrosion that's already on the part, if you have parts that come in with corrosion on them. The reason for that is because while you apply a protective layer over the surface of the part, that protective layer is also going over that corrosion, or any other soils for that matter. So while the corrosion protector is doing what it's supposed to do, there's still corrosion underneath it, and it's able to spread underneath there, and you're still going to run into problems down the road. So after you do completely remove all of the soils and corrosion from the surface of the part, is when you apply the corrosion inhibitor. And that could be in the wash and or the rinse of a parts washing application. Make sure you allow proper contact time. So if it's an immersion bath or if it's being sprayed onto the part, give it enough time so that the entire surface can be covered with this corrosion protectant. And finally, there's specific types of corrosion inhibitors that are actually engineered for specific different types of metal. So today we're mostly talking about steel, and there's the whole array of different ways that you can protect steel. But those steel protectors won't necessarily protect aluminum parts or brass parts or copper, etc. So actually, in a couple of weeks, Eric Bromley is going to be giving one of these tech to techs on protecting aluminum parts. If you want to go more in depth on that, I would encourage you on checking that out. And finally, after applying the corrosion inhibitor, you can further protect the parts by packaging them properly. So make sure the parts get cool and dry. There's no heat on the parts left over before you do this. And if you use some kind of desiccant packing material, those are really effective, and that's like VCI paper or something like that. And that's just another way to further strengthen the amount of protection that your parts are going to face. Different types of corrosion inhibitors that are out there. You can apply them with an aqueous solution, and this is going to be a dry film. So typically, you're going to dilute one of these corrosion inhibitors with water. They're usually low concentrations, so maybe 2 to 5 to 6% of the actual corrosion inhibitor, and the rest is water. That's going to leave a dry film over your part. There's also oil and water emulsion. That's a wet film. It can be sprayed, or the part can be immersed to apply that to the part. Finally, there's actual just regular oil for the most part. It's also a wet film and typically applied in immersion processes. And finally, there are also solvent-based CPs, or corrosion protectors, corrosion inhibitors. Typically, you only see those in vacuum degreasing operations. It's a wax-based material, and those are what's left on in the final phase of vacuum degreasing applications. Also, another type of corrosion out there is flash corrosion. And essentially what it is, it's just corrosion that happens almost instantaneously. Those are on some of the more susceptible metals, so like mild steel, really mild steel. Ways that you can combat that is using a cleaner that has a built-in inhibitor in it. So what you use a typical alkaline cleaner to remove oils from the face, or from the surface of the metal. And if that product also has an inhibitor in it, it's going to protect it in between the rinse. So you'll wash, and then as it's moving on to the rinse, it's being protected. It's worth mentioning that the final rinse concentration of this product is what's going to protect your part long term. So if you're washing the part in an 8% solution of this dual cleaner and rust inhibitor, in 8%, that's not going to be protecting your part long term. It's only protecting in between and doing the cleaning. Then once you get to the rinse and say it's 3% and the rinse, that 3% is what's going to be protecting your part going forward. Another way you can help reduce flash corrosion is reducing the wash temperatures, or gradienting them. So say your wash is 160 and you have 2 rinses. So then the first rinse is 140 and the second rinse is 120. And that's just differing. It's making the delta smaller from the temperature that your parts are facing in the final rinse and when they get out into the regular world. So that's one way to do it. And also, while your parts are wet, they're not going to corrode. So in most applications, you're going to have to remove the wetness, the water, the cleaning, and the cleaning chemistry that you put on the part. At some point, you're going to have to remove it. But just it's worth knowing that while it's wet, it's not going to corrode. Finally, moving on to evaluating corrosion protection methods. A few different ways you can do that with a few different types of machines. There's humidity chambers out there, condensation chambers as well, and that's actually on the left, that's a picture of a condensation chamber. There are salt spray chambers, and there's also a manual to failure option that you can always use. It's going to take longer than these other ones, but say you clean and treat a part with corrosion protective, and then just sit that part on your desk and count the days until it corrodes. It's pretty exact, but it's going to take you a lot longer to figure out what type of corrosion numbers that you have. This is an example of a humidity chamber. Labs all across the country, the world for that matter, use this to project out what kind of corrosion protection they're going to receive. Common settings are 90 degrees Fahrenheit, 90% relative humidity. And through testing with these types of parameters, it's through a lot of testing, we figured out that basically 1 day in this chamber equals about 9 days in normal warehouse conditions. So you're able to project it and say it's going to last in there for 10 days. You can reliably suspect that you're going to have 90 days worth of protection on your parts without actually having to wait those 90 days to figure that out. I believe that's all we have for tonight, so I'm going to pass it back over to Sherry for any questions that may have come in.
Thanks, Will. Great job. If you would like to discuss this topic further, please contact your local KYZEN representative or send an email to tech@kaizen.com, and we will have one of our cleaning experts schedule a follow-up with you as soon as possible. Again, we thank you all for joining us today, and we hope to see you again soon. Stay safe, stay healthy, and have a great day.